All right, we're looking at this problem over here, and again, go to the whiteboard to do it. And part of doing the problem is just looking at it, and maybe there's like an easy answer to it. I'm not saying there is, but there could be an easy answer to the question. Let's take a look. All right, go to the whiteboard, and I'll write down what I've been given. And what I've been given that 2 to the x times 3 to the y equals 12. That's pretty easy to write that down. And next one's going to be 2 to the y times 3 to the x is equal to 3. Now, by the way, someone's going to say, maybe I could just guess at the answer, and sometimes you can, right? But looking at it, I would say that if there are integer answers over here, that I'm going to say, looking at it, maybe x would be equal to 2 and y would be equal to 1. What would you get there? 4 times 3 is 12. But unfortunately, that doesn't work over here, because what do I get? If the x is 2, this would be 9. And if y is 1, I get 2, and that's not equal to 3. So then someone says, I wonder what the numbers are. And you could certainly go through this many different ways. But what I'm going to do is look at it, see if I can get something that I can solve simply. Right? So I'm going to try two different things. And the first thing I'm going to try is just multiplying. All right? So I'm going to put this over here. So I'm going to take this thing, multiply it by this thing, and this thing multiplied by this thing. Let's write this down. 2 to the x times 3 to the y times 2 to the y times 3 to the x. That's going to be 12 times 3. Now, by the way, these are equal, so I'm multiplying both sides by the same thing, which really what I'm multiplying both sides of this equation is by the number 3. All right? Let's take a look what you get over here. You get 2 to the x plus y. I'm using rules of exponent, and it's going to be 3 to the x plus y. Again, I'm using rules of exponent, and that equals 36, right? I'm going to continue to use rules of exponents, and I'm going to say this is 2 times 3, which is 6 to the x plus y, and that equals 36, all right? Now, an exponential equation, I'm looking at this thing over here, it doesn't look that bad. This is just 6 squared. So I know that x plus y, whatever those numbers are, they have to sum up to 2. I'm going to say this is a pretty important fact over here. Now, how many numbers add up to 2? An infinite number of numbers add up to 2. All right? And that's not enough. So I have two unknowns, and I only got one equation at this point. It's a linear equation, so it looks like pretty simple. So I tried the multiplication. Now I'm going to try the division. And what I'm going to do is I'm going to take this equation, which is 2 to the x times 3 to the y is equal to 12, and I'm going to divide it both sides by 3. Now, 3 is also equivalent to 2 to the y times 3 to the x. All right, now the right side's pretty easy, just number 4. On the left side, what do you get? Let's take a look. You get 2 x minus y. And you get 3 to the x minus y. I'm just using simple rules of exponents, by the way. What do I get over here? I get 2/3 to the x minus y is equal to 4. All right. This is an exponential, and I'm going to rewrite it as a log. And the reason for that, I can't think of 4 as being some power of 2/3. So I'm going to rewrite it as a log. I'm going to use base 2/3. So x minus y would be the same thing as the log base 2/3. Strange looking base, right? 4. All right? So I have two equations and two unknowns. All right? My goal here is to find out what x is and what y is. So I'm looking at these two equations. I could just add them together now. All right, so what do you get? You would get 2x is equal to 2. I'm just adding these two equations together, plus log base 2/3 of the number 4. Divide both sides by 2, and I find x is equal to 1 plus, what's going to be 1/2, right? So 1/2 log base 2/3, 4. I'm going to use the rules of logs and pull that half up as an exponent, and you're going to get x equals 1 plus log of 2/3. 4 to the 1/2 power is the square root of 4, which is 2. So I found x. I want to get y now. And how do you do that? What you're going to do is subtract these two equations. So this equation minus this one. So x minus x is nothing. Y minus y is 2y. And then you can get 2 minus log base 2/3 of 4. All right, what am I going to do now? Divide both sides by 2. You get y equals 1 minus 1/2 log base 2/3 of 4. Use rules of logs again, write y down over here. It's going to be 1 minus log base 2/3. I'm bringing the power up. The power is a half. So 4 to the half square root of 4, which is again 2. So I got my point of intersection. I'll go back and read the question to you. It says find a point of intersection. I found a point of intersection. If you want to write as an ordered pair of numbers, you can. So it's 1 plus the log base 2/3 of 2, comma, 1 minus log 2/3, comma 2. Now, granted, someone says, I wonder if that's really visually correct over here. And before I say anything, I want to point out that I got 2 lines, by the way. And these are my 2 lines over here. And you could graph those 2 lines and find a point of intersection if you want. They're not bad to graph, by the way. Let me just make sure. Yeah, you could graph those lines and find a point of intersection. Here's the deal, though. Checking these things might be difficult. Like going back over here and plugging that stuff in. I'm not saying don't check it. I'm just saying that, maybe you need a tool to verify it. I just want to briefly go back to the notes. And I want to tell you what I do in the verification department. In the verification department, what I do is I actually graph things out. And if you're wondering what I'm graphing out over here, I'm graphing out 2 lines. And so what 2 lines are you graphing out? This actually graphs out as a line. And this graphs out as a line. Oops, let me go backwards on that. I want to get my pen out. This graphs as a line, and that graphs as a line. Now, someone says, how do you know the graph out as a line? Let me just write this down. 2 to the x times 3 to the y is equal to 12. I would probably take the natural log of both sides, and you get the natural log of 2 to the x times 3 to the y equals the natural log of 12. What do you get now? You get the natural log of 2 to the x plus the natural log of 3 to the y equals the natural log of 12. What do you get there? X ln 2 plus y ln 3 equals ln 12. All right? Now, granted, this is an equation of a line. What am I saying over here? It's really like an ax plus by is equal to c. I'm expecting to see a line, by the way. Now, granted, these lines are drawn out for you, and so is the point of intersection of those 2 lines, by the way. All right? So if you do the other one, let me just go through that quickly. You would get, well, let's see, that's going to be 2 to the y, right? Times 3 to the x is equal to 3. And what do you get there? You take the natural log of both sides, make it a little better at this. So it's going to be y ln 2 plus x ln 3 equals ln 3. All right? Now, granted, let's write them in a different way. I can write them as y equals mx plus b. All right? Let's put that down. So here you're going to get y equals, well, you're going to get minus ln 3 over ln 2 times x plus ln 3 over ln 2. And that's y equals mx plus b. You could also do the other one, and you could graph them out. Now, granted, they might be nasty numbers. Now, certainly someone said, how'd you graph it out? I used a computer to graph it, but I want to say they're remarkable in their nature, looking like lines, by the way. Thank you.